2-4, solving equations with variables on both sides. So our objective for this lesson is to solve equations with variables on both sides and to identify equations that are identities or have no solution. Our essential understanding is that to solve equations with variables on both sides, we can use the properties of equality and inverse operation to write a series of simpler equivalent expressions. So we did one-step equations, we did two-step equations, last section we did multi-step equations. Now we're just going to throw one more thing into the mix with a variable on both sides of the equal sign. Now, there's many ways to solve these problems. However, usually there's one way that makes it easier for you, and that's what we're going to try to recognize as we solve these problems. Okay, so here's our first equation, solving an equation with variables on both sides. So what's my solution for 5x plus 2 equals 2x plus 14? Okay, like I said, there's a couple different ways to approach this, but what I want to do first is I want to condense the variables into one term. Okay, then isolate the variable and solve for it. Okay, so the first thing I'm going to do is I'm going to subtract 2x from both sides. Doing this will then put these x's together with these x's on the left-hand side to give me 3x plus 2 is equal to 14. Now, it's just a simple matter of solving for the variable. 3x is equal to 12, divide by 3, and we have x is equal to 4. Okay, so notice what I did. I got the two x terms together by subtracting 2x from both sides. Okay, we don't want to divide by 2x. We could subtract out the 14 first, but then that'll leave us with maybe not as simpler of an equation on the second part. Now, let's try these two guided problems. Okay, so the first one right here is 7k plus 2 is equal to 4k minus 10. Okay, and one trick to doing this, which we'll look in the second problem right down here, one trick to doing these problems is always to bring the smaller variable to the larger one. Okay, it doesn't matter what side they're on, right, in an equality. By doing this, you're going to keep all of your answers positive. So in part B, we'll look at what happens if I did the same equation from the first part backwards. But let's look at this equation first in part A. So I look at my two variables and I say, well, that's a 7k, that's a 4k. So let's bring the 4k over to this side. Okay, I don't have to do it this way, but it makes the problem easier. This gives me 3k plus 2 is equal to negative 10. Subtract 2 from both sides. 3k is equal to negative 12. Divide out the 3, and we have k is equal to negative 4. Okay, so kind of the same situation that we did up here. But let's look and see what happens if we do this backwards. Let's subtract 5x from both sides. Okay, now still I have subtracted the same thing from both sides of the equation, so I still should get the right answer. But watch what the problem is. 2 is equal to negative 3x plus 14. Isolate the variable by subtracting 14 from both sides. That's negative 12 is equal to negative 3x. And now we divide both sides by a negative 3, which now gives me that x is equal to 4. So I get 4 no matter which way I solve this equation. No matter which way I solve this equation. But here I'm dividing by positive numbers, and in part B I'm dividing by a negative. Okay, so there's much more chance of making a mistake if you deal with negative numbers versus positive numbers. So a good habit to get into is to be sure that when you look at your equation with variables on both sides, bring the smaller one to the bigger one. That will keep or give you the best chance to keep everything positive and make life easier. Let's try a word problem. So it takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? Well, obviously, hour and a quarter is better than an hour and a half. Okay, so eventually this new software will be more efficient. It's just we have to get past the 8 hours in order to learn this. So my current design time is 1.5 hours. I want to figure out where that's going to be equal to my new design time plus 8. Okay, and we're going to use h as my variable as hours. And I don't need a variable there because the time to learn the new software is not dependent on anything. It's just dependent on, it's just 8 hours, right? It's always going to take us 8 hours to learn the software. Okay, so keep this equation simple and subtract the smaller one from both sides. That gives me a 2.5 times some hours is equal to 8. Divide out the 0.25, and we get that h is equal to 32. Okay, so after 32 hours, it will take, or 32 pages, okay? So, a little mistake here, right? We should have used my variable as pages. Everything else should be the same, okay? After 32 pages, the new software and the old software will be the same. And at 33 pages, it's now cheaper to use the new software. Sorry about that. Office manager spent $650 on a new energy-saving copier that will reduce monthly electric bill for the office from $112 per month to $88 per month. So here's my variable. Make sure I got it this time. Okay, so how many months will the copier pay for itself? So usually we would spend $112 per month. I want to figure out where this new copier is going to be cheaper, but costs $650. Okay, subtract 88 from both sides, and we have 24M is going to be equal to 650. Divide both sides by 24, and we get that M is equal to 27.083. So it will take a little bit longer than 27 months, a little bit bigger than 27 months for this copier to pay for itself. Now usually you only pay bills once a month, so that means it's going to take 28 months for this copier to, the next time we pay our bill, this copier will have paid for itself. It will have saved $650. Okay? Next, solving an equation with grouping symbols. So here, I got a couple choices here as well, but nothing that will make the equation really easier. So my best option is to distribute both of these terms before I get started. So that gives me 10x minus 2 is equal to 3x plus 33. Now I take a look at my equation and I say I want to bring the smaller x to the larger one. So I want to subtract 3x from both sides. That gives me 7x minus 2 is equal to 33. Add 2 to both sides to get the variable by itself. 7x is equal to 35. And so divide by 7, x is equal to 5. Okay. Notice what I did there. Distribute first analyze the question. I see I have two variables on both sides. I take the smaller one and I subtract it to bring it to the bigger one. Okay. Now let's get a little crazy with part A. Okay. Now you don't necessarily have to do the problem this way, but you could notice that 2 and 4 are divisible, and so the first thing I could do is divide both sides by 2. This cancels with this, gives me a 2. That turns into 2 times 2y plus 1 is equal to y, these two cancel, minus 13. 4y plus 2, after I distribute this, is equal to y minus 13. Now, I don't know if that really helped me or not. Just something to think about if a situation like that presents itself. All right, same thing now. We're going to subtract y from both sides. We have 3y plus 2 is equal to negative 13. Add 2. 3y is equal to negative 11. Divide out the 3. And y is equal to negative 11 over 3. Okay? Let's look at part B. No real trick here. Just distribute. So we get 28 minus 7a is equal to 3a minus 12. Now, be careful here. I always want to bring, in order to keep my variable positive, in order to keep my coefficient positive, I always want to bring the smaller one to the bigger one. Negative 7 is smaller than 3. So I want to add 7a to both sides. Now, if you did this the other way, you won't get it wrong, okay? It'll just be a little bit more complicated, right? Because you'll have more negative numbers. So bring down the 28 is equal to 10a minus 12. Add 12 to both sides, and we get 40 is equal to 10a. Divide out the 10, and we get that 4 is equal to a. Okay, so however the equation presents itself, try to take the easiest way, but always try to bring the smaller one to the bigger one. It will make your life easier. Okay, so an equation that is true for every possible value of the variable is called an identity. For example, x plus 1 is equal to x plus 1 is an identity. The equation has, because no matter what you put in here for x, 1, 2, 3, 4, 5, if I add 1 to it both times on both sides, I'm going to get the same thing. It's true no matter what. An equation that has no solution, if there's no value of the variable that makes the equation true, like this. Okay, so no matter what I pick for x, if I pick a 1, if I add 1 to 1 and 2 to 1, I'm not going to wind up in the same spot. Okay, so this equation has no solution. Okay? So when we're looking at problems, it's possible to have no solution or to be an identity if you have variables on both sides. Because watch what could happen. 10x plus 12 is equal to distribute 10x plus 12. Okay, you could just recognize now that these are the same equation. Okay, or you could take it one more step, subtract 10x from both sides, and I'm left with something that is actually true. 12 is equal to 12. Okay, so that makes this an identity. Okay, you would say it is an identity. We can say that the solution is all real numbers. However you want to say it, we could use this symbol for real numbers that I think we should remember from the beginning. Is like an R with two little sticks on the side. Okay, any one of those is okay. Okay, part B. Combine like terms first. So 9m minus 4 is equal to negative 3 plus 12. That's 9m plus 5. Should be able to see that it's not going to work out. I could subtract 9m from both sides to give me negative 4 is equal to a positive 5. Negative 4 is not equal to a positive 5. So this one has no solution. Okay? Other ways to write no solution. Some people have seen this before. So like no answer. This is kind of a little fake. What we like to do in math when we have no solution is we like to, not a zero. A zero is a solution, but we put a zero with a line through it. Okay, that means the empty set, the null set, the set of answers is non-existent. Either one of these two is good. Let's try some guided problems. 12b minus 6 is equal to negative 6 plus 12b. I should be able to tell that this is the commutative property and they are the same thing. So my solution, this is an identity. Okay, so it is an identity. The solution is all real numbers. And here 2x plus 7 is equal to negative 3 plus 2x, right? If I subtract 2x from both sides, we have 7 is equal to negative 3. This is no good, no solution. The answer is the empty set. So when you solve an equation, you use reasoning to select the properties of equality that will produce simpler equivalent equations until you find a solution, until you isolate the variable. These steps below provide a general guideline for any type of equation that you're going to see. Step 1, use the distributive property to remove any grouping symbols. Use properties of equality to clear decimals and fractions. Multiply by a conjugate, or sorry, multiply by a reciprocal, or multiply by a power of 10. Step 2, combine like terms on each side of the equation. Okay, that'll prevent confusion. Use the properties of equality to get the variable terms on one side of the equation and the constant terms on the other. And if there's more than one variable, you want to put those together. Step 4, use the properties of equality to solve for the variable. Step 5, none of us, or a lot of us, don't really do it very often, but you should check to make sure that you are actually getting the right answer. Plug it back in, see if it works. Okay, so to finish up, solve each equation here, right? I would subtract the 3x from both sides first here, distribute, and I would get 5y on this side, 14y on this side. I would subtract the 5y from both sides here. I could, in this equation, right, well, I don't even have to. I was about to say you could try to clear the 1/2, but you don't have to, because when you distribute it, this turns into a 3, this turns into a 2, and all the fractions go away by themselves. Now, you notice that we have the same thing. Okay, so this is going to be an identity. And over here, we have 4x minus 5. This turns into 4x plus 2. This one is no solution. Okay, a word problem like we had before. Pristine Painting will paint business cards for 10 cents each, plus the setup charge of 15 bucks. The printing place offers business cards for 15 cents each with a setup charge of $10. What number of business cards cost the same from each printer? So we were going to set up the equation. So it's going to be 0.1 times the number of cards plus 15 bucks. We want to know where that is the same as 15 cents times the number of cards plus 10 bucks. I would start by subtracting 0.10 from both sides, subtract 10, and solve. Here, if I get all the variables to go away and what's left is true, that's infinite, that is an identity. No solution means it's not true. One solution means you actually get an answer. So for instance, this is 3y minus 5. This is 3y minus 9. That's no solution. 2y plus 4. 2y plus 4. That's an infinite solution. 2y minus 4, 3y minus 5. Well, I'm going to start by subtracting 2y from both sides, and I'm going to get an answer, and I'm going to get one answer. When a student solved an equation and found that the variable was eliminated in the process of solving the equation, how would the student know whether the equation is identity or no solution? Well, all you have to do is look at what is left. If it's the same, that's an identity. If it's different, that is no solution. And that is 2-4, solving equations with variables on both sides.